So the first thing to do is let's look at the structure of contracts on the left. We've got a folder or a directory for the DAO. I'll dive into that in a moment. We've got the ERC 677 standard, so that's an extension of ERC 20. It allows code to be written, or it allows a approve and transfer step to be combined in one step. We're not going to take advantage of that in Limbo because I didn't want to, well, I wanted to keep things as simple as they could possibly be because Limbo is fairly complex. The next directory is Facades, and that's a pattern I carry across from all my projects. It's basically interfaces. So in the early versions of Solidity, I think before Solidity 5, they didn't have the abstract contract. So you could either use interfaces or you would just have to inherit a fully fleshed out concrete contract. Which isn't ideal because you don't necessarily want all of your public functions to be external. So I don't like those particular bindings, so I tend to use abstract contracts. And I borrow the word facade from MakerDAO. All the DAI abstract contracts that they used were called facades. So we don't really need to go into that. It's just a bunch of virtual functions for all of these contracts. Okay, I'm going to skip past periphery. So let's start at the root level. So most of the most important contracts are at the root level. Let's jump right into Limbo. So if you were to arrive in the Limbo codebase, I would encourage you to jump into the Limbo contract. Hopefully that's intuitive. At the top of the contract, I provide a whole bunch of writing about the motivation of Limbo, about the incentives, the terminology, I give examples, I speak about Flash governance. I talk about a concept called the rectangle of fairness, which I haven't mentioned up until now. I think I'll leave it out of this talk. You can just go and read up on the rectangle of fairness. It's just a technicality on what to do with the quantity of scarcity that's generated from a migration. So starting up at the top, we've got two enums that help us manage the souls. Remember, the souls are the staking pools in Limbo. So the first is to, let's start with the second one first. So the soul type is either going to be a threshold soul or a perpetual soul. A threshold soul is a soul that is staking for migration to Behodler. A perpetual is your traditional liquidity mining soul. It's just for lockup. Then we have the soul state, and this really only pertains to threshold souls. Well, perpetual souls, it can be in a state of calibration or staking, and then threshold souls can additionally be in a state of waiting to cross and crossed over. So the crossing metaphor is taken from Greek mythology of the crossing of the river Styx into the world of the dead. So when you stake tokens and you pass that threshold that I mentioned, the staking and unstaking functionality is locked. If the tokens aren't immediately migrated to Behodler for two reasons. The first is that if it was migrated in the same transaction in which the final user staked, then that user would have to pay the enormous gas fees of migrating to Behodler, so that's not ideal. The other is that we want to preclude all forms of flash loan attacks, so we institute a deliberate delay between when the threshold is crossed to when the tokens are staked. We insist on it not being in the same block, and in fact we can calibrate, the community can calibrate to have those blocks spaced far enough apart. And the further apart they are, the more expensive it becomes exponentially to attack Limbo. So you'll notice when I was talking about migrations and pricing Flan and adding liquidity to Flan and all of that, I mentioned about targeting the price of DAI and looking at the price of scarcity and so on. So you might have been thinking that there are some oracle operations. So we don't rely on external oracles, but there is an in-place oracle in Limbo, specifically designed for migrations, with the trade-offs of migrations in mind. It's a fairly simple oracle. It doesn't need to do what Chainlink can do. It doesn't need to always provide the right answer. It simply needs to tell you when you don't have the right answer, so that you can revert your transaction. So like all oracles in mining and so on, the more you can space things apart in the number of blocks, the more expensive you make it for an attacker. So for instance, if the attacker wanted to manipulate the price of flan and then encourage a migration, if there was a 10 block delay between manipulating the price of flan and migrating at this manipulated price, they would have to keep the price artificially manipulated for 10 blocks, 10 concurrent blocks, which is enormously expensive and really infeasible. Okay, going down. The code base of the Limbo contract in particular was kept running up against EIP 170, which was put in place to limit the contract size in kilobytes deployed. So I kept running up against that, and one of the low-hanging fruit ways of reducing the size of your contract is to keep your error messages short. So what I did is I created a legend at the top of the Limbo contract with all of the error messages used throughout the Limbo process, and then I've labeled them E for error, and then 1 through to M for to number them. And whenever I have a new error that I think of, I just throw it in there. And then when I say require blah blah blah, then I'll just say in the string EE or ED or E9 or whatever it is, and it's quite quick to search. It's not as cumbersome as it sounds. I realized that what you need to do is keep it below 8 bytes, I think, in size, which I think, if I might be mistaken, but I think it's 8 characters in size. But so I could have used some short English string or some short code, but then it becomes a bit hairy, so I just use these E codes. And you'll see these E codes wherever they pop up. Just remember to come back to limbo.sol and come to the legend, and you'll see what the problem was. So like quite obvious things like token not recognized as a valid sol. In other words, if you try to stake a token on Limbo that shouldn't be staked on Limbo, you'll get an error. If you I can't remember where E2 happens, but I think if certain invariants occur or certain invariants are violated, we throw an invalid state. I mentioned that when you cross over and you're waiting, when you cross over the threshold and the pool is in a waiting to cross state, then unstaking is locked. So if you try to, on a contract level, unstake, you'd get this error. Obviously, on a front end, you're not going to get all these errors. The front end JavaScript will protect the user from having to see these things. But you need to enforce these rules on a smart contract level. I'm sure you don't need to be told that. And the bonus already claimed, that actually reminds me that I haven't spoken about one set of incentives. In Limbo, remember in the very beginning of this video, I mentioned that you don't only get rewarded for staking your tokens on Limbo, but you also get rewarded for having your tokens confiscated. Now, if you're a user who is the reason that the sol has gone into a waiting to cross state, in other words, if you're the very last person to stake a token on a threshold sol, then you don't get any of the staking rewards that happen during the staking phase. So your tokens get locked, but then if they get migrated and you aren't compensated further, that just means that you lose the entire value of your locked tokens. So there would be no incentive then collectively for the community to ever cross the threshold. So in addition to the staking bonus, the staking reward that you get that you would find in a traditional yield farm, you also get a crossover bonus, or a crossing bonus, and there are two variables that determine this that the community can calibrate. But you'll essentially be paid a batch of flan, depending on an algorithm, for your tokens that are confiscated and sent to Behodler. So this error E5 just refers to the fact that you can't claim the bonus twice. I suppose I might also digress and talk about the crossover bonus for a bit, and then I'll remind you about it when you see it in the code. But there are two variables that you can set. The one is a simple flan per token staked. So if you stake 100 sushi, and the crossover bonus is for this, the simple crossover bonus is 10 flan per sushi, then you stake 100 sushi, you get 1,000 flan. The other portion of the crossover bonus is a variable one, and it relates to the amount of time that particular soul has been running. So you can make this a positive value, so that you can say, for instance, for every second that the soul is in staking state, you will receive 1 flan per token staked. So if your soul is live for 20 seconds, then you will receive 20 flan for your tokens when they go into that crossover state. So when it's positive like that, then the incentive to join the pool increases over time, because the longer the pool is live, remember, the longer the pool is live, not the longer that you've been staked in the pool, the longer the pool is live, the bigger your variable crossover bonus will be. If that number is negative, however, so what you can do is you can say that you essentially get a penalty for every second that the pool is live. So the incentive there then is that you will have an initial crossover bonus that will gradually decline, like a Dutch auction, and the incentive for the community is to ape in as fast as possible to get the token to cross over the threshold as fast as possible, in order to prevent the crossover bonus from declining too much. So again, if you want to read more about this, our Medium has our Limbo updates. It goes into this. It has graphs and all that, makes it all intuitive. So I would refer you to that rather than taking more time explaining it here. Okay, so I'm going to move on from the errors. So there's quite a lot of calibration that happens in Limbo. Remember, the community is in charge, and because of that there are a lot of variables floating around. So for that reason we have a bunch of structs that we'll be manipulating. The first one is the soul struct. So this obviously refers to a given token that's being pooled in Limbo. The last reward timestamp, that just assists with staking calculations. Kind of took that straight from Sushi's MasterChef. So a lot of the logic, it's just adapted MasterChef logic. You don't want to reinvent the wheel too much. And that's the same for accumulated flan per share. It's also just a calculating variable that we update. Crossing threshold is the one where we decide how much of that particular native token has to be staked in order for the token to cross over into that waiting state so that it can be migrated. Obviously this only applies to a threshold soul. It doesn't apply to a perpetual soul. And then the soul type enum will then tell you whether it's perpetual or threshold, and the state will tell you what state this current soul is in. The flan per second, that's how we get our APY. So on a fundamental level, you don't speak in terms of APY, you just speak in terms of flan per second that this particular soul will be issued. And then we can use various helper functions to express it as an APY so that the community can understand it from that perspective. But it gets drilled down as a flan per second. And this is the number that you can change with governance. So then there's the crossing parameters, which is also associated with souls, and the crossing parameters have to do with, for threshold souls, they have to do with calculating those bonuses that I mentioned. So I mentioned there's the simple crossing bonus. That's the one where you just get paid a fixed amount per token staked. That's called the initial crossing bonus. And the crossing bonus delta, that's essentially the change in crossing bonus per second that the soul is live. And this can be either negative or positive, which is why it's an int. And then we keep track of when the pool entered into a staking state and when the pool ends. In other words, when the pool goes into a crossed over state. So the final user who stakes the last tokens that pushes the soul over into a waiting to cross state, that's when this timestamp will be stamped. And then we know the duration that staking was. Let's see.